All right, so this is our last video for chapter 7, and we are just going to finish up with some properties of different groups on the periodic tables and metals versus nonmetals. So a lot of this, I would assume that you already know. So just take a few moments to jot these things down, or at the very least, read through them, add in anything that you're unsure about. So hopefully we have a good understanding of the fact that metals lose electrons when they react to form positive ions, while nonmetals gain electrons to form negative ions. Metals have a low ionization energy and a low electronegativity, while nonmetals have high ionization energy, high electronegativity. Metals at STP are all solids except for mercury. And nonmetals, we have some solids, one liquid, that would be bromine, and some gases. Metals have a much higher melting and boiling point. Nonmetals are lower melting and boiling point. Metals are shiny or have metallic luster. Nonmetals, solids tend to be duller. We obviously would not describe a gas as being dull, but we're talking about the solids here. Metals are malleable, which means that they're bendable. Nonmetals, again, the solids we would be describing, they are brittle. So you try to bend them, they just break. They don't have that movement to them. That has to do with the way that the electrons are arranged. So we will revisit that idea when we talk about bonding. Now these last, ductile, which means that it can be drawn into wires. So that kind of encompasses your malleability, because it's got to be shaped. And also the fact that metals will conduct electricity. And that we should add on to our list too, that metals conduct electricity. Then these last two are reactions. So these two we're not going to be as familiar with. So metals react with oxygen to form oxides that are basic. So if you want to think about that, it could be like magnesium. So magnesium solid plus oxygen gas would form magnesium oxide, MgO. We made a 2 there and a 2 there. That magnesium oxide would be basic. Then they also react with water to form metal hydroxides that are basic. If we think about when we did the sodium metal demonstration in Regents, sodium metal put into water created quite a violent reaction. It produced a lot of hydrogen gas and quite a bit amount of heat, so much heat that it can ignite that hydrogen gas, and it also produces sodium hydroxide and heat, because that is exothermic. So if you use that as your example, it will be a lot easier to remember that reaction. So sodium metal plus water makes hydrogen gas, so you see it bubble, sodium hydroxide. So if we tested the pH of our solution after the reaction, it would be high because we had made a strong base. And then it also releases a lot of heat too. With our nonmetals, they react with oxygen to form metal oxides that are molecular, covalent in nature, and acidic. So we can use an example to remember that too. So let's say we take carbon plus oxygen would give us carbon dioxide. Carbon dioxide will combine with water to make carbonic acid, which obviously is acidic. That's one of the reasons why soda is acidic. We also have the same reaction happening with our sulfur with oxygen to make SO2 or SO3. Those are things that lead to acid rain, making sulfuric acid and sulfic acid. All right, our alkali metals, group 1. So we have to remember that alkali is group 2, or sorry, is group 1. And then we just go through those properties. So group 1, highly reactive. Remember, sodium with the water, highly reactive. They have a low ionization energy, so they lose electrons pretty readily. As we move down the group, we will see the ionization energy decrease. So they lose electrons even more readily as they move down, which makes them get more reactive as they move down the group. Lower melting point and more metallic, which really just means that they're going to lose their electrons more readily. They oxidize easier. Oxidation is loss of electrons. So again, group 1, highly reactive, loses electrons easily. And again, we have that same reaction that we talked about on the previous slide. Sodium plus water would produce sodium hydroxide and hydrogen gas. Alkaline earth is group 2. They will lose their electrons fairly easily, but not as easily as group 1 does. So group 2 are still reactive metals. They're more reactive than the transition metals, but not nearly as reactive as the group 1 metals. Halogens, group 17 or 7A, depending on which numbering system you are going by. So those are our nonmetals, highly reactive. They gain electrons very readily. So they have high ionization energy, high electronegativity. We have fluorine in there, which has the highest electronegativity on the table. So when we get to bonding, we will talk about how fluorine has reacted, not spontaneously, under high temperature, high pressure with most of the noble gases. So fluorine, if anything's going to react, it's going to be fluorine. So fluorine will remove electrons from pretty much anything. So it's got that really high electronegativity because it's a small atom, but the nucleus is very close to the valence shell. So it's able to attract in new electrons. So X is just generic halogen. So we could do this for fluorine or with chlorine. So we have hydrogen gas plus say Cl2 or F2 would make HCl. So again, we can use that to help us learn that. So it's easier to remember the example. All right, our noble gases, group 18 or 8A. We know a lot about our noble gases. We know that they are pretty much unreactive because they have a full valence shell. So they will exist as monatomic atoms, meaning that they stay by themselves. And they have completely filled S and P sublevels, making them very stable. They used to be called the inert gases, but as I said on the previous slide, they have reacted typically with fluorine under high temperature, high pressure to make some different compounds. So therefore they had to change the name from inert, which meant unreactive, to noble gases, which means that they are stable and relatively unreactive. And again, all of the noble gases have reacted with fluorine non-spontaneously, so high temperature, high pressure. And helium was the last one that they were able to get to react because helium going to have a very small radius, so that nucleus is very close to the valence shell. So the attraction between helium's valence electrons and the nucleus is going to be greater than it would be in the other noble gases. The bigger noble gases would be slightly easier to react. All right, allotropes. Allotropes is different forms of the same element in the same physical state. So we have a couple of examples of that. Oxygen O2 gas, that's the oxygen gas that we need to breathe in. O3, the ozone layer. So they both contain oxygen, they are both gases, but that's where their similarities end. They will have very different physical and chemical properties. Same thing with diamond and graphite. Graphite is your pencil lead. Diamond, we know what diamond is. Clearly, they are very different. So they do share in common that they are composed of carbon and that they are both solids, but that's where your similarities end. They will have very different physical and chemical properties because they are bonded together differently. And again, we'll talk more about their structures when we do bonding in a little bit.